Good morning, class. I'm going to start out. You might get a couple videos from me today in these little short snippets while I'm still working on the longer lecture series that will be on YouTube. So bear with me. Um, I looked over your answers to a number of your responses for the question from yesterday, and as you can see, right, I have table G in the background here. The question read, you have a solution that contains 14 grams of KCl, potassium chloride, and it's in 100 grams of water, and it's at 40 degrees Celsius. The question says, what is the minimum amount of KCl, potassium chloride, that has to be added in order to saturate the solution? And some of you were pretty close on. Some of you were way off, and a few of you actually even asked me, could I explain? They weren't quite sure. All right. So, in the TOCO method, I don't have a board in front of me, obviously, so you got to listen really carefully. You write down all of your givens, and what do we know? First off, we know that we're dealing with 100 grams of water in the solution, and that's what this graph is based on: 100 grams of water. And they tell us that I have 14 grams. But the most important thing is for us to notice or to note at what temperature is the solution at. And they tell us very clearly it's at 40 degrees Celsius. So to use the graph, we need to find the temperature and the material. This is KCl. That's this graph. My little pointer is working here, right? So at 40 degrees, right now, it has 14 grams in it. So I find 14 grams, right? I don't really need to find 14 grams on the graph, but what I do need to know is at 40 degrees Celsius, what's the maximum amount of potassium chloride that can fit in 100 grams of water? So I read up from 40 degrees Celsius till I hit the KCl graph. And that's almost 40. I'm going to call it 39 grams. Now, there's already 14 grams in the solution. So 39 minus 14, 39 minus 10 is 29, 28, 27, 26, 25. We're 25 grams away from the maximum point. Therefore, the minimum amount of solute in the form of potassium chloride that I could add to that solution would be around 25 grams. Now, if this was a multiple choice question, obviously you would have picked 25. But since I made it an open-ended question, it's all relative to what you decided this number was. If you called it 38 or you called it 37, well, your answer would reflect that. I'm calling it 39. Therefore, 25 grams would be the minimum amount. And the reason maybe that part of the question confused you. What do you mean minimum? Well, I could have thrown 100 grams of potassium chloride in there, and it would definitely be a saturated solution, but it'd be overkill. It would be overkill. All right. At 25 grams, that's the minimum amount I need, and boop, it puts me right on that graph. Now, what would have happened if I did, in fact, dump 30 or 40 grams of potassium chloride into 100 grams of water at 40 degrees Celsius? Well, it would be a saturated solution, and there would be residue on the bottom of that beaker. Let's say that's what we're using, right? Imagine that, a beaker with 100 grams of water in it, which would be 100 milliliters, because the density of water is 1 gram per cubic centimeter or 1 gram per milliliter. So as I dumped in the extra, I'm sure you've seen this happen if you add salt into water, say, you're just going to see those particles descend to the bottom of the beaker. All right. The liquid part would be saturated with an abundance of extra on the bottom, which would be waste. All right. Not to be confused with a supersaturated solution. That's when we force extra solute to stay suspended. All right. So with that being said, I hope that answers your question. And I'm going to do another couple of these videos momentarily and put them up there for you guys to watch. See you soon.